Okay, so I am excited to be joined again today by Phil Lessner, CTO at Yageo Group. And this time we're not together, we're halfway around the world. And we're sitting down to discuss the future of the capacitor industry and the market and technology needs for ultra-thin capacitor, a technology that's being developed by Smoltek. But before we start, could you just quickly give a brief introduction about yourself and your role at Yageo?
Sure. I'm Phil Lessner, Chief Technology Officer at Yageo. So my role is to really overlook the R&D efforts of all the product business groups and look for cross business group collaboration there. In addition, look at future technologies that Yageo may not have today and see how they might be integrated into the Yageo family of products.
Great. So just quickly to start off with, our shareholders are, of course, really curious about how our continued collaboration looks like. And we're still, to some extent, working together. For example, Yageo is helping Smoltek evaluate Gen Zero samples. Could you share your thoughts a bit on how you see the interaction moving forward and why you're still interested in working together with us?
Sure. Yageo considers the CNF-MIM capacitor technology, which is carbon nanofiber metal insulated metal technology, a promising future technology. Our customers continue to ask for thinner capacitor solutions for high-speed applications, and the Smoltek CNF-MIM technology is one path to that goal. It has the potential to leapfrog the other capacitor on silicon technologies that are being offered by other capacitor manufacturers.
And these silicon capacitors, so they're pretty new in their field. And I know we've spoken earlier about the need of new capacitors to fulfill the need of emerging technology. What would you say are some of the largest technology demands from customers, and what type of performance is needed to fill that demand?
Well, customers are putting more and more functions into the same space. And an example of that is mobile phones, which now have multiple radios, cameras, and sensors, and are getting more functionality every year in essentially the same form factor, package size. So downsizing all the components in both footprint and height is one key to achieving this greater functionality in the same form factor. The other trend is that power demands on application processors for mobile are getting more demanding as we move toward artificial intelligence on mobile devices. This means that moving the capacitors closer to the application processor in order to meet these voltage stability requirements is an absolute must, and the CNF-MIM technology is an enabler of that.
And one of the solutions to these emerging needs are then these so-called ultra-thin capacitors. We've heard that kind of being floated around in the industry for quite some time, but can you elaborate on how they would solve the problems and the needs that you just described?
Mm-hmm. So yeah, I define ultra-thin capacitors as capacitors less than about 100 microns in thickness, or a tenth of a millimeter. And really they fulfill the need of being able to be placed underneath the application processor, therefore saving space and reducing the distance between the capacitor and the processor. So the saving space is what I alluded to in the previous comment about more functionality in the form factor, but then this reduction in distance also gives the capacitor the ability to provide fast enough energy to the processor to make sure it has a stable voltage, which is critical for the proper application of the processor.
And what are the applications, if we move into that space a little bit, what would you see are the applications for ultra-thin capacitors, Smoltek's capacitor technology being included in that, and why?
Yeah, so currently most of these silicon capacitors are being used as land-side capacitors under the application processor, providing the speed, energy needed for these high-speed mobile applications. They're used there because the thin profile allows them to be mounted directly on the underside of the application processor.
And what are the emerging applications on your radar, or are there any as you can see?
Yeah, I see many possibilities for CNF-MIM capacitors going forward. In addition to being mounted on the circuit board or under the processor, there's also the possibility of embedding them inside the circuit board, which would save even more space. Ultimately, the CNFs could be grown directly on a silicon substrate, silicon interposer, or even the silicon processor die. And then, unlike the deep trench capacitors, which are limited to a silicon substrate because of the process, the CNF MIM capacitors have the possibility to be integrated on other substrates like glass interposers, which is a emerging technology out there, or even other substrates like alumina or potentially less expensive silicon substrates. So there's potentially also a cost advantage as well as a technological advantage in the future.
So could you speak a little bit more of the cost reduction aspect? How do you see that the CNF-MIM technology could lead to a cost reduction in the future?
Yeah, so semiconductor grade silicon, great substrate, but it is fairly, costly. So the ability to use other substrates, maybe non-semiconductor grade silicon or glass or alumina or something, could potentially give a big cost advantage in the bill of materials, and the CNF is ideally suited for this because it can be deposited on any substrate. I mean, there's also the possibility of flexible substrates like polyimide or something in the future to make flexible caps. So that I think the possibilities are here pretty outstanding for future work.
I mean, that is one of the benefits of the CNF-MIM technology, since we don't technically need to use the substrate to be able to increase the capacitance density. Then it,
right. We say
it's
silicon caps because that's the initial substrate of choice, but it's not limited to that is the point.
No. And when we've been speaking to customers, both together and individually, we've understood there is a big need from the market for these ultra-thin capacitors in different shapes or forms. Could you comment on how you see the market evolving and what role you think that Smoltek could play in that market?
Yeah, I think the power needs for mobile devices will continue to grow, especially with the recent advances in generative AI and the push to bring that technology to laptops and phones. This is going to create the need for more capacitors closer to the processor, which is an ideal fit for ultra-thin caps in general and Smoltek's technology in particular.
And how do you see the market growing in the upcoming years?
Yeah, the move to AI is going to the edge is going to create a replacement cycle for laptops and phones, in which this technology could be incorporated. And then we can't ignore, other markets like wearables, like smartwatches, and smart rings, and other things, which is a growing segment and space, and it's even more constrained in terms of space in these devices, which also makes Smoltek's technology a great fit there.
Yeah, well, it looks like, for the technology in itself, it has a very promising future, and there's a big market need for it. So those are pretty much all my questions today. So again, Phil, thank you so much for taking the time to speak with us.
You're welcome, Louise.